Hello everyone, so I'm still Pierre-Yves, and I'm still going to talk about the upside and downside of Python for command line application. In a specific case, the Mercurial case. I'm working on Mercurial for about 4 years, and I'm now full-time Mercurial developer paid by Facebook. So this talk was originally made with a Mozilla employee called Alexis Metero. This is why these slides are nice HTML5 presentation, and this is also why they are nicely buggy, and I'm going to blame Alexis for it for the whole presentation. So, why did Mercurial pick Python when it got created in 2005? That's the main argument that you will hear in other cases. So it's very easy to make a proof of concept in Python because you have a lot of battery included and you don't have to care about a lot of things. It's cross-platform, so it's very easy to have something running on Linux and Mac and Windows very quickly. It's not super fast, but it's definitely fast enough for running. And it's very easy to refactor, play with ID and things like that. You don't have to fight with the whole complex type system to do anything and implement a lot of layers of anything to get anything done. So it's very easy for having fast development cycle. That's an exchange between a random IRC user and NPM, which is Mackall, the creator of Mercurial. In that exchange, the user say, I really like Mercurial, but I really would like it will be in C instead of Python. And Mackall say that, well, if it was in C instead of Python, it would have taken 6 months instead of 2 weeks to get a prototype. And Mackall have been a Linux kernel developer for a long time, and I've been writing C before that. So it's not, he knew Python, and he didn't know C. It was actually, he knew C very well, and that was a good argument to pick Python that he didn't actually knew that well at that time. And a good example of that is on April 19th, Mackall announced Mercurial after like 2 weeks of playing with the IDE. On May 9th, we have an HTTP server for displaying things and doing all network exchange protocol things. And in June, we have Windows support, so we are already supporting the biggest user base everywhere. But now that it's done, it's a project that is running for 10 years, and there is things happening. What are the actual advantages for the users? As I'm at the PyCon conference, I can appeal to actual users here that as it's your language of choice, it's easy to hack on it if you want to change stuff. And it's also very, very easy to extend. We're going to go back to the exchange part, after the extend part after that. How do we write extension for Mercurial? But first, we have only one official API, because Mercurial is primarily a command line tool. It's not, it's happened to be written in Python. It's not a Python library, it's a command line tool. And having too many different API and too low-level API slow down developments and make it very hard to refactor if you have to support very low-level assumption. So the one official API for Mercurial is a command line. It's very stable. We have mostly the same behavior for stuff that are 6-year-old. It's also very powerful because every other people that don't do Python want to interact with Mercurial through the command line. And we actually have multiple libraries to interact with Mercurial in various languages. And what they do is they actually start a long-running Mercurial process and talk through it using the command line API and output. We have one for Python too, that still goes through the command line API. So, for example, I want to know how many each people in my project how many commits did all these people. So the easy Unix way is I say aglog -- template author to only get the author name. and I sort it, and I unique -c it to have only one line for every user and the number of people and the number of occurrence of that line. That's the Unix version. You can actually do that directly with Mercurial using some magic here. You ask for revision in the form of sorted or revision sorted by users, and you don't have to do the sort directly. That small thing is a ref set. A ref set is a query language for Mercurial that allow you to do a lot of things. So you can ask all the transet done by Alexei, or you can ask for all the transet done last week that touch a Python file, or you can ask for all the change between 2.8 and 2.7.3. You can also ask for, and you can combine all that. You can do subtraction, addition, all kind of thing. It's very powerful. I'm not going to go in detail with that, but you can basically select any kind of revision on any kind of criteria using refset directly from the command line. But there is still some interest to go directly through Python instead of using the command line. So we don't have an official API, but all the top level things are pretty stable. We don't guarantee they will never break, but they are pretty stable. It's Python, so it's also quite Pythonic. So you can create a repository given its path. Then we are using a default it for stat, and we can quickly iterate on all the revision in the repo, get a transet object, and ask the user of the transet. And we have our statistic for how many people did how many transet, how many commit in my repo. And that thing, that is quite simple, is very easy to turn into an extension. We have a lot of helpers. I skip the import, otherwise it doesn't fit on the screen. But you say, okay, I have comments. I have a command that is called stat that doesn't take any kind of arguments and doesn't have a help because it doesn't fit on the slide. But then I directly get the repo, and I can do the same thing as I just did, and then I have a special UI object to output things. But that's pretty much the same code that I did before. Directly in an extension, I can say hgstat and add the thing. And it has some advantage. So it allows you to access lower level stuff that are also less stable. But having things in process allow you to have much direct access to the information and have much faster performance for some stuff. Let's talk more about performance. So the common conception is that Python is an interpreted language, and therefore Python is slow, and you can't use Python for anything serious. The thing is, whatever language you pick, there is other factors than just if you're using a fast language or a slow language. The algorithm you use to process your data and do your things are very important. So here is the kind of speed up we gain in Mercurial by not changing language, but just changing the way we do things. So we have something called add remove that is going to look in your repo for all the files that are unknown to Mercurial and on all the files that are known to Mercurial but no longer on your disk, and say that, okay, all the missing ones are removed and all the new ones I don't know about are probably added. And so it do a bunch of comparison with dictionary and things like that. And on very big repo, it can be slow. So we had the next speed up by just changing the order we process stuff and having faster comparison. And the same Python algorithm moved from this is too slow to be used on Facebook size repo to this is perfectly fine. It works also on C. We have a lot of SHA-1 because all transets have a SHA-1 and all files have SHA-1s and everything has SHA-1s. And so we built a special data structure to store and compare SHA-1 and find SHA-1s back from C to C, and we have a 40x speedup, which makes the whole searching for SHA-1 not a problem anymore. If you want good algorithm, you have to have data that let you have good algorithm. So let's pick a bit on how Mercurial is storing its data. We have basically three kinds of data, three categories of data in Mercurial. We have the files, so the content of the file you're actually storing in your version control and retrieving from your version control. We have the manifest, which is a list of all the files in a commit, and we have the commit itself. This model is basically the same as the Git model and comes from Monotone that existed before both of them. So when you make a commit, you will store all the content of your file into something called file log, and you keep the SHA-1 of all the files you have committed into a big flat files with the name of the file and the hash called the manifest. And the chanset say, okay, that person at that date did that commit for that reason, pointing using that, and that commit contains that manifest. All this stuff use the same thing called a revlog that do an efficient storage of like all the file content for all that. So when you do your first commit, you're obviously storing a full snapshot of your file, because before you had no data for the file, and now you have data for the file. So you store all the data for the file and you compress them, but that's the details. So you store a full snapshot, that's a gray thing at the bottom. Then you start having new versions of that file that are likely a small change compared to the previous version, because you're changing a couple of lines in your big text file. And so you store diff again that previous, again the full snapshot. And then you have a third version, so you store diff again as a second version, and so on. But at some point you have too many diff. That's what Subversion was doing, and applying thousands of diff is very expensive, and also required to read a lot of data and things like that. So when the amount of diff become as big as a full snapshot of the file, we store a full snapshot of the file again. That way we have a good compression rate, because we have a compression rate of the order of diffs we have, but we also have a good access time, because you never have to read more than twice the final size of the file when you store it. And that's the kind of thing that make the language choice less important. If you have a good thing on disk, most of your time you're going to spend reading data and applying data, and having that part in Python or C is not going to be that important. There is all other interesting things with that model. With that model, you only add diffs or full snapshot at the end of the file. And as you only add things at the end of the file, you have nice property like easy transaction. When you start a transaction, you know how long your file is, and you add stuff. And if your transaction fails, well, you go back to the initial size of the file, and all the data are automatically discarded. But it also has some drawback. If you want to travel your file revision from the newest to the oldest, you're going to have to apply diff in like reverse order and read your file in reverse order, which means that you're traveling your disk in reverse order, which is less relevant now that everybody have SSD, but was quite relevant in 2005, where everything was on spinning disk, and some stuff are still on spinning disk. So having the list of revision on the repo is basically twice as slow if you go the wrong way than if you go the right way. So good data structure give you speed and nice algorithm, but it comes with constraint, and sometimes you have to like follow the flow. But so, to be honest, Python is still slow for various operations like big loops and input-output things and things like that. So there is about 5% of C in the code base that focus on replacing the core part. We do that a lot for everything that is reading and writing on disk. All the very core stuff like computing a diff, applying a diff, a lot of the indexes, and a lot of graph algorithm. So all the things that find what is an ancestor of what, this kind of thing. The way Mercurial is architectured means that you can replace like some object or some function by a C1 without having to rely on the whole code base knowing what is in C and what is in Python. So Python is great, but it's not always great. We just said why it's a good choice to pick Python, but it also comes with significant amount of constraint. For example, calling function in Python is slow. It's about 60 nanoseconds per call on my laptop, which is really small, but it becomes 60 milliseconds if you do 1 million call. So if you have a transet with 1 million something, and you have function call for every something, you're going to have 60 milliseconds for just calling the function, not doing any work, just calling the function. And 1 million functions come quite fast, and 60 milliseconds is quite a lot for a command line tool you want to return in under a second, under half a second, for like reactive action. The same way creating objects in Python is really slow. We saw the thing before where we iterate on the repo, and on the repo we ask the repo, we get the revision number, and from that revision number we get the transet object, and we use the .user method on the transet object, which is very Pythonic, but creates transet object. If we skip the creation of the transet object by directly asking the raw data from the changelog, we get half of the time, because half of the time of fetching the user was actually spent into finding and building object, which is quite bad. Also, we still have a global interpreter lock in Python, which means that you cannot easily do parallel stuff. There is a lot of stuff you can do in parallel in Mercurial, like when you retrieve a revision, you have 20, 30, 200 files that you need to retrieve the content. You could compute that content in parallel, but you cannot easily do it in Python because you cannot do multi-threading. So we do some forking stuff where we fork workers that have very specific work to do, and then we have to add more complicated logic to make sure that they don't write on the same file descriptor at the same time, and things like that. This works okay on Linux and macOS. Forking on Windows is super expensive compared to anything you want to do in Mercurial. So this is quite a big constraint in today's world where every machine has at least 4 cores. Something else that is not so much relevant for Python usually, but quite a pain for command line tools that want to get back to zero quickly, is the startup time of Python. Having a hello world in Bash is under a millisecond. Perl is 3 milliseconds, but Python is like 10 milliseconds, and Python 3 is 20 milliseconds. So all that adds up quickly into the user experience. It also goes with imports. The import process for Python is quite powerful, but also quite complicated, and requires to stat a lot of things, and is quite slow. So importing big stuff like command wells is almost a second for not doing anything with it, just loading it. So we don't import wells actually in Mercurial, but that's a good example. So we have something called lazy importing, where when we ask for a module, we don't actually load it, because Mercurial knows how to do a lot of things, but usually the user wants to do only a narrow slice of what Mercurial can do. So we are going to only load the module that are required to do that. So we have lazy importing that is going to load module on demand when they're actually needed, and this is gaining us like half of the import time on most stuff. So it's got much better, but like setup tools and eggs that are getting replaced by wheel. But eggs are actually installing everything into their own directory and adding a new entry to the sys.path every time it's installed something, which add a lot to the search time, because every time you import something, you have to look at every entry in the sys.path until you find something. And so the longer your sys.path is, the longer that search is. Garbage collection is also slow. Well, it's something that affects everything with garbage collection. But if you have a lot of container, your garbage collection can become like a lot of container. Container is about everything like direct dictionary, which means object, or tuples, or list. And the more of them you have, the slower your GC is going to run. And this is actually impacting us in multiple places. By chance, using the C API, you can disable GC for objects that you know that you will never have cycle and things like that. But this is something tricky that you have to start caring about and losing some of the advantage of Python of not caring about memory. Something that is getting fixed with Python 3 and is great is typing. So Mercurial is a 10-year-old code base, which means that we have it starts to be legacy territory. It's not that bad, and it's not that big, but still, you have some stupid issue with bugs, with types, or functions that are never used anywhere or used wrongly and things like that. And we have a stupid bug somewhere because we are comparing a string with an int somewhere, and we were thinking that the bug was much more complicated, but eventually we find it, and it was just that. That could have been catched by anything that with typing. So Python is great as long as you don't call function, don't create object, don't have multi-core hardware, don't write a command line tool, and don't need garbage collection. So what about the other DVCS? How do they do? There is another one written in Python called Bazaar. It's interesting to mention because they had issue with their format. So the way they store data on disk, they change it multiple times, which means breaking compatibility multiple times and losing, annoying user every time. So getting your format right so you can write good algorithm on top of them early is really important. Something else that killed them is the internal Python API. They went to we are Python program, so we are also Python libraries, and offer quite low level API in Python. And enforce backward compatibility on them quite early. And this slows them down in being able to refactor stuff, because when changing the format, it means that some functions were no longer that relevant, but they still needed to work, and therefore they added slowdown for a bunch of things so that can still work the same way they used to work. The Bazaar people made a retrospective of everything that works and everything that didn't work. It's very interesting read. I encourage you to read it if you have time. So Git is the more popular and very similar version control system. Because it's in C, and so it doesn't have any startup time thing, and some difference in its format is going to be much faster for stuff like exporting, logging the whole content of your repo on the chunset level, having the status of file on disk and things like that. It's going to be about the same when you come to the size of the repo, because the way they compress their data and the way we compress our data are very similar. Are going to be the same on diff, because the way you retrieve it and you compute it is going to be about the same. And operation a bit complicated like rebase is going to be similar too. On the other hand, they're going to be slower because of choice they made in the format for stuff like clone, pooling, update, because we use multiple processes to do the update. Logging a specific file because we have the history of every file and they don't, and blame for the same kind of reason. A huge repo like Facebook size, and getting a bit there from Mozilla size. Git is unusably slower than Mercurial because you can do a lot of extension that cut some corner or optimize some stuff in core Mercurial to handle that repos that big. Which brings us back to the beginning of the talk, where Python is easy to extend, and it's become very relevant when you have actually AV extension needs, like Facebook have. So Facebook have something called Watchman that replaces the whole object responsible for knowing for the status, so knowing what file have been changed or not. And so instead of looking on the disk to know what changed, it use a kernel level event to know at any time what changed. And when Mercurial asks it's there. And we can return instantaneously. The same way we change the way we compress so that we have a less good compression but much faster compression. And it's easy to do from Mercurial because you can just monkey patch something somewhere and like from an extension. We have remote file log that breaks some of the DVCS assertion by storing most of the file content remotely so that you don't have to download them. That make pushing and pulling fast. And we have HGSQL, which is a journal of everything that happens to a repo, because it's very, very easy to plug at a level that let you know everything that happened in the repo and replay it on various things. That extension allows us to have multiple master in write mode, which means that if our main Mercurial server dies, it's fine, because we have 4 other Mercurial servers master, and we are still running. Okay.
Thanks for a great talk, Pierre-Yves. Put your hand up if you have a question, and I'll run a mic to you. Any questions? Oh, it's always over the other side.
I was just wondering if you have any insight about building a command line tool and using libraries along with that. How do you bundle them all into one place, or how do you get it set up to run your code that you need these external libraries? Does that make sense?
The question makes a lot of sense, and we decide to have as few as possible external dependency for Mercurial, because Mercurial is version control, and therefore it's keeping history, like it's an archive software, basically. So having the simplest possible archive software ensure people to be able to have a running Mercurial as easily as possible in like 10 years from now to get their data back. So we explicitly avoid external dependency. So I cannot answer your question, but that's a good one.
Are there any more questions? Nope.
Just a sort of a supposition that a lot of the faster alternative Python implementations rely on a JIT, and that would be inapplicable here because it's a command line tool that you're going to start up and it'll exit very quickly.
So your question is how is PyPy useful for Mercurial and speed-wise, right?
I'm supposing that it wouldn't be because it's JIT format.
And so the issue with any JIT right now is the warm-up time. Like the JIT run the same, like find function that are run multiple times, like hotspot that run 10,000 times, and then compile them, and add an overhead for the whole running by doing all this instrumentation. It's not very useful for command line tool, because when you have run 10,000 times your loop, you're probably done with doing what you're doing. So when JIT has some kind of memory of what happened and things like that, or if we can store some state of the thing, it's going to be useful. It's also useful for web servers using Mercurial. So Bitbucket is thinking about it, and we talk about the how we have like API in different languages that talk to Mercurial to a long-running process. We are having an experimental client that is a small C client that talks to a long-running Mercurial process so that you don't have the startup time cost, and that would also probably benefit from PyPy. PyPy people play with Mercurial, and without the warm-up, it's much faster for multiple things.
More of a general question about VCSs. So like 10 years ago, like Git solved this problem of like centralized versus decentralized. Yeah. So like where do you see like big problems right now, or like what are the trends where this whole development is going? Mm-hmm. Or would you say that like version control in general is more of a solved problem and we are like now just like twiddling the knobs?
So the main issue in the VCS field right now, in my perspective, is ability to rewrite history and exchange history with people. So the ability to like send a pull request to someone that give you feedback and rewrite some of that, and not like adding more crap on top of that, but actually does make your exchange set better and keep exchanging that with people. That's currently quite painful with Git, and I can point to multiple Linux emails yelling at people for rebasing stuff. Mercurial is working on something called chance set evolution that is tracking the rewrite so that you can detect and solve problem automatically. It's far too long to fit into that answer, but that's probably the new front of VCS.
Well, that's all the time we have, so everybody please thank Pierre-Yves.